Welcome back, Psygeeks. Hello everyone. So today we are going to recap a bit what's happened last time. And so we are going to make a quick recap of where we left. And it was some time ago, so it will take some time to recall all the concept there. But then we start from there and we try, at least, that's my hope, to include another piece to the puzzle. That is, okay, now I have my Dagger pipelines able to do pre-process steps or multiple tasks one after the others. The next step would be, can I substitute some of that piece, some of that steps with I don't know, you can call it uh, automatic procedures that are driven by AI. So I delegate part of my daily routine to a generative AI. And yeah, it can sound like tricky or cheating in certain sense because uh, we already know how to do those steps. We just make AI triggering and managing different setups or different flavor of our request. But you will see that probably that there is room for this kind of activities and for this kind of task management. So the idea is this one. Let's first of all recap where we left last time. And all right, so we did a lot of things actually, and that were two long episodes of almost 2 hours. So I'm going to produce a summary video soon after this live, so you can get the whole picture without losing too much time, just highlighting the core concept and the core test that we did. So the idea was pretty simple. We want something to reproduce our data science pipeline everywhere and be consistent in doing that. So we want to leverage the Dagger runtime that it was thought to be reproducible because you want to execute, for example, continuous integration on GitHub Actions, but also you want to reproduce the very same task on your laptop. So with that idea, the concept here is, okay, let's use this feature for our data science pipeline. So I want to package my download of the file, my pre-processing step, and share with my colleague or with other people the whole pipeline without losing compatibility or without losing time to understand different environment. I want something really containerized in the very sense of the term. So Dagger runtime was the first cool thing. We installed everything we needed and we were ready to go. So Docker runtime, Docker engine, and Dagger command line. And then we create three main block inside this Dagger runtime that are called Dagger functions. And we create a function to import dataset from Kaggle. We created a process that can be executed and chained one after the other. So this is a unit of processing. You can do one step of the processing and then pipelining this to another one. You can put whatever number of processes in this pipeline as you want. So this is the core of the unit. And then we included the last step that is, okay, either launch my Jupyter Lab instance so I can continue to work on this data, or take this Jupyter Lab step and transform this into a debugging step that, for instance, means just let me go and spawn a session, a terminal session inside the running container. Which are these functions? Basically, they are operations that has been executed by the Dagger runtime one after the other on a container interface. We are going to see this in practice. I do not want to put too much effort in describing all the nitty-gritty details, so you will touch them with your hands. So all in all, you will have, from the user perspective, something that is really a black box that exposes some arguments and options, and you can make them combine as you need. So you can import data, do whatever kind of processing you want, simple Python scripts, for instance, or Bash script. And you can either download the results of these operations directly on your host, so extracting from your isolated environment the data that you need, or you can continue working in this sandbox, if you want, with a service exposed. So you will be able to log into the Jupyter Lab that is running inside the Dagger runtime and continue operating and prototyping stuff. So this is what we did. What we're going to do today is the following. Is introducing, well, first of all, we're going to do two things. We left last time with something that was working, but it was not really user-friendly because all the operation arguments that are available weren't described so well in the code itself. So Dagger could not expose more details on how the things were working. So now we're going to document and see how you can produce some basic documentation in the code that can be exposed in the Daggerverse. We left last time with this concept. The cool thing of all these functions is that they can be packaged into modules that you then share with others in a registry, if you want, that is called Daggerverse. So you see here a lot of stuff. We are going to publish our code after we document everything. We document everything and we see how we can do that. So documenting. Then we are going to introduce, that is the core of this episode, we are going to introduce a second flavor for this box. So what we are going to do today is taking this one. Yes, it's a process, but it's a special process. It's a GPTScript process. What does this mean? Means that we are taking this technology from the Acorn Labs, that is the GPTScript, and we are going to use this like a special bash script. Special meaning that I can instruct AI to do special operation. In our case, we are going to ask it to download or to open a CSV file, understand what's inside, and do some preliminary operation that can take time for you to write, but are so typical that you do not want to lose time on. So one of that is, for instance, all right, GPTScript, take this table and encode in one-hot encoding with a one-hot encoding method all the column that you consider string categories, right? So pretty usual stuff that you do on basically most of your use cases as a data science and also as a scientist. But then AI is able to do this on your behalf without making you losing time on retyping time and time again the same snippet of codes. So this is just one example, of course. And the cool thing again is that since this is a simple process, so it's a function inside the Dagger module, this will be chained as much as you want. So you can have in principle a GPTScript process that read data, and we are going to do this actually, read data that has been imported via Kaggle dataset. So we download data first, then we ask GPTScript to clean up stuff and do things for us. Then you can either chain this up, everything from command line and passing important information from the command line. You can do a whole data analysis pipeline like that. So GPTScript again, then all right, I'm pretty okay with the result. Now it's time to be serious. So please AI, stand by while I'm evaluating the results. I'm doing some fancy stuff, and eventually when it's done, I will store either my data or I will end up in having all the inputs that we need for the Jupyter Lab session, right? So this is the plan. Documenting Kaggle Dagger module with all the processes, introduce a GPTScript special process, and then put everything together and see what can be done. Few examples, then you can extend as you want. Eventually, we are going to publish this module, and you can start from there and do two other cool things. Importing this module or this function in other modules of your own, So you can set up different kind of modules that use, for instance, just one part. You may say, okay, I need just the process of GPTScript in my module. I don't need everything else because I'm going to do some special stuff. I do not use Kaggle, for instance. I do not use JupyterLab. I don't care. I just want this. Okay, so we are going to learn how you can import a module and use it in your code. And then the other cool stuff is that you can we write here, I wasn't particularly confident in writing Python, so we took some time to with some stupid error. But then the concept is, okay, I can either write a module or a code in Go, for instance, in Golang, and then you can still be able to import modules that are written in other languages. So these are the two core concepts that make me love this kind of approach. So you have Lego block, you have really self-consistent blocks that can be imported in any language, in any other module, to increase the complexity of what you need. All right, so I think it's enough with talking. I don't know if you agree or if you have any question. Otherwise, yeah. Otherwise, we can get started. I took some optimization records since last time, so we need to recover from where we left, and I explained here step by step the topology of a module. So this is a module written in Python, and we did this for readability, but mainly because this is the language that if you do data science, you're most fluent in. And this is not my case. I'm a cloud infra person that accidentally in the past worked as a scientist, a physicist in particular. So I know something I'm not fluent, I still might be. So let's start. The module is a class that we call Kaggle Dagger, and then the class itself is configurable through these variables, and one of these is lab container, so we can select the container from where we want to start with. And then we have also the working directory. So these are the two fundamental information for the chaining process. And then we implement functions. The first function that we have is, all right, let's take the self-lab container, so the container that we are working on in our chain, and wherever you are, stop it and launch a bash session. Okay, so this is for debugging. Where you code the debug function at the end of a pipeline, you have been logged in basically into the pipeline. This is cool for debugging and developing stuff. Similar but different is the JupyterLab part. So wherever you are, take a token that will be the password to log in on the JupyterLab instance. That is a type secret, and return a container that exposes the port 888 and launch a Jupyter notebook. So again, wherever you are in the pipeline, stop it and launch a JupyterLab. So I can find all the data that I produced in the sandbox and I can start play with them. All right, and then the core, the meat if you want. So the import data function, here we are using Kaggle. You can use whatever you want. You can also put flags here to enhance the capability of not downloading only from Kaggle competitions, but also from everywhere else. In our case, we pass the API keys for Kaggle, and we select the competition we want to download. In our example, we're going to use the Titanic dataset. That is the one where you have to forecast the probability of survival of passengers based on some ancillary information. And right, so import data, and then you see here you start to understand how things are going to work. You take the current status of the locked container, and then from there you do additional operation. So for instance, we are working directory, that is the working dir that we select. Then we mount a file that is the PI key file that we indicated, so the file containing all the secrets for Kaggle download. You install the needed packages, so in this case the Kaggle packages, download the competition and unzip it. Done. And return self. This is the trick that we saw last time. If you return the self type, it means that this function can be chained. So this function, for instance, can be chained with the previous ones. And so I can call import data and then Jupyter Lab, and the Jupyter Lab will return eventually a container that I can use. The other function that return a self is the preprocess data. Return a self because we want to either import data as much as we want in the pipeline, and also pre-process data. So I can chain different pre-processing one after the other based on the succession, based on the order that we call it. So here again, we mount our our task dir in this case with our pre-processed code. We install the requirements. You see, it's really customized around well-defined process. You can enhance and extend as you want. It's really basic to make you understand what can be done with this kind of technology. And eventually execute my pre-process step. And that's all. So what we did last time, it was pretty much this. As you can see, we did not document too much anything, and so it's not tricky to understand how this works. But the cool thing is that this module is already good enough to be executed locally with some, okay. So we are doing an experiment actually. We are taking this, and I think that if I manage to test.sh, so if I manage probably to create a script, it will be clearer for you how this whole chaining thing works. So okay, let's give it a try. As I told you before, we start with import data. Import data called working dir, API keys, and competition. That's all. So we stop here, and this is the first step of our chain. At this point, we have a self type returned, so we can call any kind of other function that is supported by our module. And yeah, probably I'm going to do the following. Let's see exactly. So now here I can select, oops, sorry. I can select yes. So the first one is import data, cool, returning self. The second one is pre-processed data. Pre-processed data, yes, this one. And then, okay, requirements files, we pass everything to this stuff. All right. But this was the old implementation, so what is taking as argument is taskdir preprocess 1, and then the other argument is name preprocess 1. Right, cool. So this is everything for this step, and eventually we are then on the last step, that is take the secret from the environment variable called token, bring it up as a service app, and voila, we have our pipeline that we can summarize just one command and run it wherever we want. One thing that you can do, again, since these are self-type, you can chain whatever kind of modules and requirements and different kind of scripts one after the others, reading the output from the previous one. So this is already supported, and it is how it's going to work. All right, you start seeing the power of all this stuff. One missing step is nice. We still need to introduce the GPTScript stuff, and we want to introduce the description. To do that, let's see how you can publish a Dagger module, and you can see that you have simply to put here the repository where you store your module. So I'm going to put the repository where I save files, and I send you also, this is the version of the, I'll send you in the chat. So this is the module that I pushed before, and this is this is what we are going to insert here in the Dagger module. And in the Dagger module, then we are going to remember to remove the HTTPS and publish. Voila! So you see that now everyone can use and discover my module, and you notice something already. You notice that the description here is the one that we have in the code here. So we already know at this point that we can put a description, more significant description, telling, okay, the Dagger module to chain data science operation in a reproducible environment. You can chain Python code and GPTScript prompts in any combination you want. All right, so you can put some example, and I can put already bash. Oops. I don't know if this works, but we are going to discover it soon. Right, so for instance, we can put an example of how you can call things. And okay, oops, no, oops, sorry about that. Okay, and okay, who knows, maybe it's gonna work. And we can store, and then we can go git status, git add src main and init.py, commit with significant message. As always, scientists love to do these things. So demo commit for self documenting modules. Only for you, I never do this with so much details. Joking apart. So we are going to commit and push. Right? Now if we manage to publish again, let's see how it goes. Oh, please tell me that I have this. Yeah. All right. So I have. Oops. All right. Loading module. We should have a different version now. Yeah, no, unfortunately I cannot pass a markdown somehow. Yeah, I'm going to ask around and the dev people and see how you can do that. But all right, good enough. You can put some example and show how this whole chain work. Then you have all the function with example, and for instance, Dagger debug. Okay, I don't know why it's not working. So the function are called correctly. We need to see in the cookbook how you can do examples, I suppose. Execution function, chaining. Yeah, you know, this is supposed to learn together, so it's good. But yeah, I don't want to lose too much time in documenting stuff, and I want to directly go to the GPTScript stuff. GLSDK, API reference. Yeah, I saw somewhere, what's a recent video, how you can put examples in your code. I cannot find it. All right. All right, never mind. Let's go ahead. We have a lot of stuff to do. So, good. What we want to do now is the following. I want to introduce, yeah, no, maybe not here, but here, a different kind of pre-process, right? I want to introduce here this kind of pre-process. Pre-process, GPT file, and name GPT cleanup. What does this mean? It means that, okay, we can close this. It means that we can now edit this function and introduce a different one. And the different one will be based on GPTScript is installed here. Yes. On something that is pretty powerful and pretty cool. GPTScript. So I introduced already what I meant before. So you can define I have a video, I invite you to look at that, where you can do physics analysis. This is an example with taking open data from CERN and doing a simple analysis, where you take your environment and you describe different tools. Tools are, you can imagine, like functions that you can call in a bash script. But the only difference is that these functions are run by AI. What does it mean? I teach actually the, let me zoom in. I'm teaching here the AI that a function called loaddf exists, and this is the how in natural language I'm going to recall it. So a Python loading branch for file that it's called data into a data frame named df, and the argument of this sentence or this flavor sentences will be the data frame, the data I want to download, and the branch. Once I have this information, this is the piece of code that you have to run or to introduce into a Python script. So same for initialization stuff. And or also I want to draw something. So again, I will have my function, the description of my function, the arguments, and what you should do. What the function should do, it depends. Can be, for instance, in our case, appending new Python lines to our script. Can be downloading stuff from the web and do scraping and do a search. Or can be what we are going to do is open the CSV data, download that into a DuckDB, and do some queries to help us, and then store the output somewhere else. And how you do this, once you have the function, you have to do your bash script. And your bash script is essentially a file with the extension GPT, just to have idea what's running inside that. And you can call separate predefined functions, so you can tell the AI that can run, execute commands, can write on the system, and eventually use the module that I defined. With that module that I defined, then the AI will be able to understand what I'm asking for. So writing a Python script contains the following blocks, and each one of them do something different. So code to import root, code to load branch events, and so on and so forth. So the idea is that now, if I execute this with GPTScript, I will be able to, with an API key from, for instance, from OpenAI, I can send this as a prompt and retrieve the result of executing the script. So the AI is managing a sequence of tasks for me. And the simpler and most basic steps can be really successful substituted by AI. So AI can help you in normalize and make in natural language all the steps that you don't want to do anymore. That's my idea, and that's what should be in reality, in my opinion. So how we are going to produce our first GPT script. And very similar, just one more thing. Just one more thing. Ouch. I just forgot to update this. Now we are in GPT script process. Okay. Now we are in this step. We're introducing GPT script to do the operation I tell you before. So GPT file doing the following: defining my tool that is taking a tool that is already defined, and I show you where you can find these tools available, and also download files in case the files are not there. the name of the tool will be clean and encode. And what this module does is load a CSV file and read its schema, then clean up the information, dropping rows with null values and encoding all the columns with categories using one auto encoding method. Eventually save the output in output. Perform then this task, what the operation that has to be done, are described here. One task after the other, so open the CSV, read the schema, based on schema drop all rows with null values. You can also be fancier here. And based on schema again, encode all the columns that you find to be categories using one auto encoding method. Store the results on the CSV. This is the step that we want to pass to our machinery, to our Dagger module, and say, after importing data from Kaggle, you can do this on your own. I don't want to pass you all the nitty-gritty detail, all the Python script that I run time and time again in an explicit way. I just want to describe in natural language what you have to do to clean up my data. And yeah, and that's the idea. So once this tool is described, then I can use and do the actual task. So do one task after the other. I take the train CSV and do the operation described in the module. And I also take the test CSV and do the same to have the same transformation for both train and test data. All right, hopefully this will succeed, but we miss two information. Who is this guy here? And how I can import and define my function in Dagger module to do this kind of achievement. All right, so let's take a look at GPTScript toolbox. The toolbox is meant to be the very equivalent of the Daggerverse. In Daggerverse, you can navigate all the modules. In GPTScript, you can download and work with every toolbox that has been published. So, for instance, we can take this one, CSV Reader, and make a search. And let's see what this is doing. You see, it's described as a toolset that is able to read CSV file and make queries using natural language. This is just what we wanted actually. We have an example, and so we take inspiration from this example, and it also has some internal schema and internal tools. And we see that, for instance, we are going to need to install DuckDB, but because all the transformation of the data will be done using DuckDB. Right? So yeah, I think if there are no questions on the chat, yeah, I think we are ready to bring this this part of the processing into our pipeline. How can we do that? We can do that in this way. We take our function, we define a new function in this way, a new function that we call pre-process GPT, and then after self we also pass name. In this case, we want to have a unique identifier for this operation, and we passed the we can pass a secret for our OpenAI token, so we can call it in this way. And yeah, just a second, I can split vertical and then open a second one that is init.pix. Yes. So yeah, just for sake of time, I'm going to define this function. So the function will be something like this. So I define the name, the GPT file, that is the one responsible to execute the operations, and the OpenAI token. That's all you need. And what we do then, we take the self-lab container, we define it as, okay, we define it, we mount the GPT file, so we import from the host to the Dagger runtime our GPT file. We install GPTScript via pip, for instance. We download DagDB and we put it in user bin. You see here I use with user root. I moved to user bin, then I came back to Jovian, that is the user inside the Jupyter lab. And I put the OpenAI key here that I can pass as a secret, and eventually I run my GPTScript process with the GPT file I passed. I put this or echo because if you want to debug, this operation should succeed. So either the failing of the process shouldn't stop you from doing spawning a terminal in this session. So it's a good, to me, it's helping a lot wherever I need to debug things. So feel free to remove it, but for sake of this demo, I'm going to keep it. Right, so we have, again, different function. It's time to document them a bit. So pre-processed data is responsible to execute a Python script passed from task there with dependence depths into requirements.txt. And in this other case is instead, okay, let's do it this way. Execute a GPT script file with the given open AI token and DAC-DB available for data analysis operation. One thing for which we use DAC-DB and we do not ask to, well, that module, the CSV reader, is not using Python to the analysis, is because AI is very, very good in general to do queries. It's an SQL magician, basically. So you can imagine a lot of information are around to be trained on. So the idea is I'm using DuckDB. The module will use DuckDB because AI gives its best when doing SQL queries. And we will see this in practice. Okay, so the functions are defined. Cool. Oops, okay. Sorry about that. So the functions are defined, and all right, cool. The functions are defined. Sorry about the repetition, and we can go now and do our best to understand what's happening. So, all right. Sorry for spamming around. we can take our test sh, comment these lines. Well, no, actually, it's what we need. So we're going to test this. Ch mode +x test. Dagger test, okay. Let's see. Okay, and Dagger test.sh. Right, so Dagger is going to start, and what it's going to do is this one. So importing data. All right. Yeah, working there is not of the function. It is a parameter of the call of the module, not of the function. So we need to put import data here. And by the way, last time we saw also that if you do Dagger call -h, you will be prompted with all the information of the parameters that you can set. I don't know why initialize is so slow this time, but yeah, you see you have all the functions with the description, you have the arguments that you can pass to the Dagger module, so the directory and the lab container, the required one, are highlighted here. So you'll have everything. Now we should be able to execute our script. Oh, working there because we are not into the correct directory. So now let's see. And OpenAI token is not there. And okay, it's not there, so we are going to export. Oh, right, so cat just a second, I'm changing because there are sensitive data that I don't want to share. Just a second, almost done, resist. All right, so we've done it. Export, open, outscored, open AI API key, and we, all right, so I just imported the key. I can back to this one and selecting a new chapter, so testing AI processing with GPTScript. Okay, so now you should see this one, and cool. So now this time we should be the good time. And GPTScript again, this one, oops, I can go export token for the Jupyter Lab. Test me, please. All right, cool. It's starting, it's downloading the image at the Jupyter Lab. It's downloading then the Kaggle competition. And soon it will be able to pass to the next step. So after doing the import data, it will be able to do the pre-process GPT OpenAI. Yeah, it will take some time to download the dataset. I don't think will be too much, but yes, just for your comprehension, we are at this stage. So the Dagger runtime is executing the first step of our chain. And don't worry, I can understand that this looks like a bit complicated to chain via command line. We are going to soon see how you can start from scratch installing a module and define your own code. So either your own module or your own code where you run just one piece of all the tasks that you are doing, or all together. That's up to you. So you can either run in a command line interface or executing it in a more programmatic way if you want. So it's taking a while. Shouldn't take too much time. I mean, we are on a remote machine, so it's not either my fault here. And okay. All right, so here we are. We are now at the cleanup stage. So AI, please go ahead and do what I'm asking you to do. I'm installing at this stage, I'm installing all the dependencies for GPTScript and DuckDB. And then eventually I will start soon installing DuckDB, executing the command. All right, now it's time to shine for GPTScript. That should be able to call the OpenAI function services. And here we are. DuckDB, copy the data that I stored in the previous step and do, first of all, the cleanup. So this stage is going to do remove all the rows with null values. So under the hood, on the runtime, Dagger runtime, it's running a DuckDB process, ingesting data from the CSV and doing this fancy stuff. So now you can just imagine how many operations you can do in this way. You can either ask GPTScript or passing a Python script to do, for instance, well, I want this to spawn a batch job on a powerful machine with 8 GPUs and do inference of my model and come back with the results. This can also be one step of your chain. Now, the operation that I asked to the preprocessed GPT step end up well, and I'm passing here to this chain, to this task that say, okay, launch a Jupyter Lab, cool, done, with a secret that I indicated you before, and bring up a service that can be exposed to my host. Now, to check that everything worked, we are going to do the following, and going to look at 0.008. Cool, Jupyter Lab is going, so it's already something. I'm logging with the password that I set before, and we are prompt with our Jupyter Lab. And here we have all the data that we set up before. So we have, for instance, the original trained CSV. So we have all the columns for, we have sex, that is a category, keep it in mind, and we also have embarked, that is a category, for instance. We also have cabin, that is not filled many times. So what we generally speaking told to the AI is not so correct. All these rows will be removed. But yeah, we can go and be smarter with the prompt, so we can tell, okay, remove just the column that are null values, the rows that have null values, with the exception of the cabin, right? And or fill the cabin null values with a certain value. This is something, a pre-processing step that we can chain before doing this one. And then we have the pre-processed test and train that are the one generated by the AI. And you see that passenger ID is cool, class is okay, female is okay. It did not do what we expected. So it happens. It happens. And you have to be extra careful. Yeah. You have to be extra careful with what you do, because you can see here, for instance, that on test and training CSV files, the operations that have been performed by AI are not the same. So let's take a look again. We have in the train process, it did actually what we asked it for. So it has additional row, additional column with sex male and sex female. So it's one auto-encoded the two sex options, and also 3 column for the 3 embarked options. And you see again is one auto-encoding. So we are partially satisfied. AI did what we expected to do. But if I go here on the test sample, I'm afraid, yeah, that it didn't do what we expected to do. Yeah, not at all. So it's not trivial. It's something that takes some time to make in operation, but once you nailed it, you can do a lot of stuff in this way. You have always to check, of course, but again, you have the possibility to introduce something like this. And you have the possibility to introduce something like this, as I mentioned before, not only, oops, let me close this process, not only on your own, but standing on the work of other people that are playing a lot with this technology. It's pretty new, it's changing a lot, it's also coming with a lot of new stuff that will help also in a graphical way. But yeah, we are in this situation. You can pass GPTScript together with process that are written in Python. Not only that, you can also, if we go back to our code, now we can do something very, very, very cool, and I show you briefly. So let me comment this, get status, git add im. Okay, you will bear with me, although I'm doing this nasty thing. So I'm going to push, and I'm going to publish this version. So Daggerverse, you know how it works now, right? So you do Daggerverse, GitHub, Cargo Dagger. I'm publishing, and I have a new version of my module. It would be even better if I tag it, but yeah, That's all. And come on. Come on. All right. So we have Kaggle Dagger, and we have now the additional type at the end, that is the pre-processed GPT. Cool. Again, also this technology is pretty new. It's going to change and put this additional stuff like the examples that now is not working. I promise to share with you all the information that you're going to need. But all in all, let's see what happens when I do this command here. What does it mean installing a Dagger module? So you remember you can start from scratch and say Dagger init --sdk python and the name of child module. So it will be a module that will import our Kaggle module, and we see how we can import single function into our code base. By the way, I'm not working with as a Dagger developer. I learned everything I'm sharing with you from the documentation that is very well done. This new version is even better than before, and you have all the information on how to develop different kind of things in different languages and different SDK that are supported, and module versus function, execution environment. Okay, let me see if yeah, okay, sorry. Okay, so we have now a child module. We are inside, and we can paste the Dagger install that we did before. What it's doing now is that now from this new module, we will be able to call the function defined into the previous module. So we will be able to import a Kaggle Dagger class, basically. Let's see if it's true or not. Dagger develop, if I remember correctly. Dagger develop in order to load everything. Yeah, we're almost there. Stay with me. We have Dagger develop, and we are going to import this. So we go inside cd Dagger. Yeah, exactly. We are going to integrate with the module layout. Yes. I don't know, let's see. Three 3.12 install, and we have install, and we have right. Let me, before I forget, let me just editing the title. So now we are importing existing Dagger modules. All right. So now we are porting this. Install dot. All right, installed. So now we should be able to go inside here and define a module. Okay. Let's see if, for instance, we can import Kaggle Dagger. Yeah, I'm learning with you. Probably I'm going to ask help from Kaggle, from Dagger. No, let's check together. Yeah, that was the last attempt, so clearly it's not going well, but import module. Okay. Yeah, that's a pity because if I managed to do something like that, but I do not have the description how to import stuff. Let's see, for instance, if this is working. Tag presentation. Probably. Let me check. Probably it's already imported. So let's see. Dag dot no. Not something it's out of. Dag Kaggle Dagger. Either the ID is not working or yeah, I installed the module and I don't get why I don't have. Yeah, module dependencies. Okay. Dagger install module we did that. Dag hello world message. So working there. Let's see if it's just a matter of my IDE or Dag. Okay, and then yeah, come on, this had to work. And then is the back. right? So it's returning a container. Return a container. Okay. So now from here we do Dagger. Call container equal minus minus working there, this one. Let's see. Function client has no attribute. Okay, so now I have the doubt that didn't execute this, but yeah. Calcul Dagger. Maybe I'm too tired, but this should have done this already. Probably not at this point. Sorry, huh? Dagger dot JSON. Okay, cat Dagger.json. So the dependency is there, and if I call it, now it should work. Otherwise, we have problem. I cannot see. How this differ. So this hello world. How is done this hello world? Let's see. Hello world. So okay. Install an hello world module from your own modules code. Let's take a look at this. Oh, it doesn't exist anymore. Maybe in this branch. So we found, okay, I need to highlight this. Okay, so let's check if the documentation is working. Otherwise we can open a ticket, I think. Okay. Yeah. All right. And then we are going to do what is suggested here. Just like this. Dagger call. Greeting. All right. So I executed the same command as the guide. Let's see if it's working. Otherwise, we are going to open an issue and we're done. I think we are ready to go to sleep a bit earlier than usual, but let's see. Okay, this is working. This is working, but why? So pip install. It's let's see if it's matter of translation. Yeah, probably. Can be. So working there, yes. Working there. Let's see. I think we nailed that. So we nailed that. Fucking yes. Let's see. All right. So container. Oh, working there. Come on, come on, come on. Come on. Container evaluated. Holy moly. STD out. No, STD out of the container won't be. So terminal. Should be able to log in into that. All right, so let's recap. Yeah, it's working. Cool. So we installed. Once you install our module, you will be able to code. I don't know how to fix this into the IDE, but I'm going to check. You will be able to call all the functions. So this is the bug, but can also be something like pre-process. Oops. GPT with its parameters plus the bug and so on and so forth. So you can chain whatever you want and do your code, importing the function that are defined in other places. Cool. And not only in this way, but as you can see here, you can do that also importing my Python modules into a Go code base. Again, you can take GPTScript to execute a single process of your pipeline and let's be serious. So full screen, we do import our data. We make it clean and pre-processed as we want with GPTScript, making smart enough, make our prompt smart enough to be able to chain different operations and be consistent. Then we can also execute some script of our own, probably with some framework that are not very well documented, that only us can do and configure, or Anyway, we can also delegate to different machine some heavy operations for GPU with GPU inference, for example. This can be a step managed by a Python script that we implemented. And the last but not least is I will be able to download data produced in this way. I will be able to use GPTLab to debug and prototype further. And I also will be able to very easily log in into the Dagger runtime. I can implement the very same chain into a container integration pipeline. It's born basically for that, Dagger. And I can also reproduce this everywhere. Everywhere I have a Docker engine or a container runtime, I can reproduce these results. So how cool is that? I think I have a lot of fun learning every time. You see, these things are changing very quickly, so you have to stay tuned. But yeah, the potential is huge, and so I'm looking forward to see how you can use these setups. And if you have any idea to go ahead and rework what I did, I left you in the comments also the reference for this module. But from the Daggerverse, you should by now be able to find it. So thank you all. Thank you for staying with me until now, and see you on the, well, first of all, on the next video that will summarize the all three lessons, all three live sessions. And then we're going to go back to some Kubernetes heavy payload offloading. So meaning virtual kubelets. Let's see what we can do. I have also some machine learning use cases that I'm wondering if we can invite to these slides. So yeah, there are some stuff to stay updated with, on the social networks, and subscribe to YouTube to be tuned for the next episodes. Yeah, next episodes, summary of these sessions, and new one, how to use virtual kubelets, interlink, and even Kubernetes GPU, a virtual kubelet initiative related to machine learning and data science workflows. So yeah, stay tuned and talk to you on the next episode. Bye bye.